Okay, yes. A very good afternoon to all of you. Welcome to this online class where we are going to continue from where we stopped last week. Now, before we begin, I want you to go to joinmyquiz.com, or you can also use your mobile phone, download the app, Quizzes, and then use this code to join the quiz 158122. Now, this quiz we are only going to take about 10 to 15 minutes. It's more of a review quiz, and then after we are done, we are going to download the scores, check for the attendance. So don't take it very seriously. If you can do it, fine. If you cannot do it very well, don't worry so much about it. It's more of attendance and a review of what we learned last time. Now, the code will be described there in the comments section. Use your name or your nickname to log in. One more time. You can use your name or your nickname, but don't forget your room and your number. If your number is 5 from 5, number 20, log in as 5 from 5, number 20. I can see some of you have already logged in. 5 from 4, number 39. 5 from 7, number 16. All of you, you're welcome. Still have only maybe, yes, 5405. That's correct. You can also log in like that. This means this is 5 from 4, number 5. Okay. So I'm still waiting for you to log in before we begin the short quiz. Take about only 10 minutes to do it. Okay. Only have a few. Okay. Still waiting for you to log in. I'll give you some time, 5 minutes to try and log in before I click on start. Have they ever used this application before? In my class, only my time 3. Oh, okay. This is the first time for them. Okay. But I think with other subjects they have done it with English. I think they have done it with English. Oh, okay. So some of them are but this one they have to download the application. Yeah. Oh, okay. They have to from the App Store. I will type the application name. We're now at 62. I think we can do better than this. I'm still waiting for you to log in. 63, 64. Okay. When you hit 70 and above, we'll just start the game. But I can still give you some few minutes before we start the activity. Okay. Okay, that is 82. Still waiting for some more. We hit 100, we start the game. We hit 100, we begin the game. Okay, 86. 2 more minutes, then we start. 2 more minutes, then we begin. Okay, 87, 88, 89. Still waiting for you to log in. I will use this activity to check your attendance and also to give you some extra points. 91. 91 students. 92. We hit 100. We begin. Okay. 7 more. Okay. 93. 93. 95. Okay. 96. BB05. Okay. Safe name. Unsafe name. Remove them later. Okay. One more, then I click on start. Okay, one more. Okay, there we go. 100 is good enough. So, ready, steady, go. Do your best and your very best and hope for the best. Again, don't take it very seriously. Just try to relax and be as calm as possible. So, ready, steady, go. The rest can join in as the game continues. 105. Okay, there we go. Start. Good job. You're running around 40% accuracy. 41, 43. Okay, good job. Keep it up, keep it up. Okay. Okay, 5 from 3, good job. Keep it up. Isaiah 5 from 1, number 34. Keep it up, good job. Donald Trump is the best. What's your number, Donald Trump? Don't have your number. Make sure you keep using your number. For Donald Trump. Kobe Park still leading. Okay, that is Kobe Park 5 from number 9. Good job, keep it up. 5 from 1, number 6. Good job, keep it up. Okay, accuracy has improved 52%. Doing well. The path 5 to 3, number 5. Keep it up, good job. Okay, 130 players, that is good job. Okay, again, don't forget to log in using your name and number. Name and number. 5 group 3, number 9. Keep it up. 5 group 2, number 32. Keep it up. Good job. 5 from 1, number 34 is Isaiah. Keep it up. Good job. 5 from 1, number 6. Keep it up. 5 from 1, number 9. Keep it up. Almost done. Some of you almost done. Okay. About 51%. Not so bad. Just beyond the half mark. Half mark. 125. So far, so good. Keep it up. Check the spelling. From number 20 to 25, check the spelling. How many finished? Okay, here we are. About 5 minutes. Try to hurry up. Still waiting for your slots. Some of you are finished. Okay. Others are still waiting for them. Okay. 72 have finished. 140 minutes. So 73 have done. So we are halfway now. When we hit 100 students, when 100 students will have finished, I will click on continue. So just try and hurry up. Try and hurry Okay, those are 3 students have finished, 84 have done, 6 have finished. And wait until we hit 100 students. Those top 100 who finish 100 first, keep on stop. Okay. 99 students have finished. 99 have finished. So when we hit 100 and just click on enter. So 99 so far. 100, 102 out of 147. 103. 104, 105. Hurry up. I'll give you an extra 1 or 2 minutes to try and finish up. An extra 2 minutes to finish up. Okay, so far so good. 107. looks like 5 from 2, number 32. Just see it like you're leading at the ball also. It looks a very good score. 45, 53, 9. Give it a shot. Job. 5 from 1, number 6. Anything from 5 from 8? I'll check the score later. So we have 109 students. 109 students have finished. 1 more minute. An extra minute. Then finish. I'll just click on end. 111. Okay. Now we have 151. 112. 114 are finished. Those who have joined the activity links, just remember this. Don't take it very seriously. This is just a kind of a warm-up to help us review what we've been learning for the last 2 weeks. What we've been learning for the last 2 weeks. Good job. Okay. All right. 30 seconds. 30 seconds. Okay, 115 are finished. That is a good one. Now, those who have not finished, don't worry about it. We always have the next time, that is tomorrow, right? Or next week, 160. So, let me stop so that we can be able to continue from where we stopped last time. Okay, I'm showing what to end. And yes, I just did it. Okay, all done. Again, one more time. I will use this to check the grading and also to check your attendance. You can see your scores here and the percentage of how you've done. I can see some who got 76% per question. But don't you worry, we are going to go through these questions later on for your recording purposes. So don't worry about that. Now, again, as we begin the lesson for today, on the comment section again, don't forget to key in your number and also your name and also your room. For example, if your name is John, key in the comment section as John 5 from 2, room 5 from 2, number 6 or number 7, depending on your number. Okay, now the unit we are going to study for today is about the topic motion. And the subtopic will be the graphical analysis of motion. It's not a difficult topic as such. It's a continuation of where we stopped last time. Now, today we are going to only concentrate on distance time graphs. Distance time graphs. Then next period, next week, we look at speed time graphs. But before we do that, let's look at what we learned last period. We talked about the following keywords last week. Motion, we see that motion is any movement that changes its position. We looked at that last week. And also we looked at scalar quantities. Quantities that have only the magnitude. For example, in this topic, distance and speed are scalar quantities. Then we also looked at vectors. We said vectors are quantities that have both the magnitude and also the direction. For example, acceleration. Another one is velocity. We looked at distance. We say that distance is the actual path taken of any moving object. And the difference between distance and displacement is that distance is the actual path taken. Displacement is the shortest distance between the initial and the final point. This is a vector. This is a scalar quantity. That was last week. And also we looked at speed. We said speed is the can be found by calculating the distance, dividing the distance by the time taken. And velocity, we say, can also be found by dividing the displacement measured by the time. Acceleration, we say, is the rate of change of velocity divided by time. And also, we looked at the unit. The unit of distance, we say, is meters. SI unit, meters, meters per second, meters per second, meters per second squared. Now, very quickly, I want us to look at, sorry for this, having a little problem, distance time graph. On the distance time graph, I want you to consider the car that is moving in a straight line. when you look at it in that aspect, you'll find that the distance time graph is also the displacement time graph. So we can use this distance slash displacement time graph. It uses just the same format, almost a similar vocabulary is also. Sorry. And also, we are going to divide this into different scenarios. Hold on a bit. Time will be on the x-axis and distance travel will be on the y-axis. Now, we are going to look at different scenarios. One, we look at an object at rest. How does a graph appear for an object at rest? We said last time that an object at rest means an object that is not moving. There's no movement in it. It's stationary. It's not moving. Now, it is at the same position at all times. It is not moving. For example, a car in a parking bay. Let's take for instance, at what time and also again, sorry for this, having some technical problems with this time and distance, x and y. The distance will take on the y-axis, and the time will be on the x-axis. For instance, at 0 seconds, this vehicle has moved. It was at 20 meters. Again, at 1 second, again, still at 20 meters. There's no movement at the same position. Another one at 2 seconds, again, no movement, 20 meters. 3 seconds, again, no movement, still at 20, it's stationary, it's not moving. And 4 seconds, again, there's no movement, still at 20 meters. 5 seconds, again, but it's not moving. Graphical representation of this looks like this. Those are the distance in meters is on the y-axis. Time is on the x-axis, so just look at the points. 1 second, it will be 20. All of it just to find that we form a straight line. In a graphical representation for a car at rest is a straight line. So if you see a straight line in a distance time graph, if you want to interpret that information, it simply means stationary object. The object is not moving. The object is stationary. It is at rest. Scenario number 2, or example. Scenario number 2, we can look at a car that is moving at uniform velocity or constant velocity. We can also see constant speed. In that case, how does a graph look like? Remember, moving at uniform velocity of 20 meters per second means it travels 20 meters every second. After every second, it moves for about 20 meters. Again, using the graph, we can look at time and distance. Then, for example, at 0 seconds, it has moved 0 meters. Then at 1 second, it's moving at 20 meters per second. So that means at 2 seconds, it will move an extra 20, that is 20 plus 20. It will move at a distance of about 40 meters. At 3 seconds, it will move an extra 40 plus 20. It will move a distance of 60 meters. Next one we have at 4 seconds, it will move a distance of 80 meters. And the last one at 5 seconds, it will move a distance of 100 meters. 100 meters. Now, graphical representation of an object that is moving at a constant velocity or uniform velocity looks like this. So you graph these details that we have. The distance on the y-axis and the time on the x-axis. So 0 at 0. Then 1 at 1 second, you have moved at distance of 20. The next one, at 2 seconds, it will have moved a distance of 40. The next one, at 3 seconds, it will have moved a distance of 60 meters. And as you can see, it's making kind of a straight line. Straight line when you interpret that. And then when you join the initial to the final position, it forms a straight line. It forms a straight line. Now, the slope of this straight line, or how steep it is, whether it is very shallow or very steep, determines, or you can be able to interpret it depending by knowing whether it is moving very fast or it's moving very slow. But we'll come to that in the next few slides. Scenario number three. This is acceleration. Huh? When a vehicle is accelerating, it means that it's increasing its speed. When it's accelerating, what happens? In acceleration, it means the distance traveled per second keeps on increasing. For example, again, time and distance. Where you have 0 second, then you have 0 meters, then you have 1 second, you're moving at a point of 2 meters, then you increase at 2 seconds, there's an increment, right? From here you see there's a difference of 2, there's a difference of 2 meters, that is 4 meters. At 3 seconds, it's a 7 meters, there's a difference of 3 meters, a difference of 2 meters, so there's an increase in the distance traveled. Next, at 4 seconds, you can see there's a difference here of another 3 meters. Then there's a quick increase from 10 to 16 with a difference of 6 meters. Now, the graphical representation, it's already here, you can see the curve, showing that there's an increase in acceleration also. So at that point, you can look at the points here, again, 0, 0, then 1 at 2, then 2 at 4. It's a small problem with my graph here. Again, 3 at about 7, and then at 4 seconds, it has moved about 10 meters, and at 5 seconds, moved at about 16 meters. So this graph simply shows you an increase in the distance traveled, keeping on increasing as the time moves on. Next one we have is how do you interpret this information? Okay, number 4, deceleration. Deceleration means like it's slowing down. Acceleration is an increase of speed. Deceleration is when it seems to slow down. How can you graph this kind of an information? Again, similar, the graphs time and distance at 0, 0 here at this point. Then again at 1 second, the distance traveled per second keeps on reducing, keeps on increasing. 1 second is at 10 meters. 2 seconds is at about 19 meters. 3 seconds, it's about 25 seconds. 25 meters, sorry. You can see there's a decrease. There's a decrease from 1 second to the other second. The distance traveled. At 4 seconds, again, there's a decrease of about, here we have a difference of 9. Here we have a difference of 6. And here we have a difference of 3 meters. Right? You can see there's a decrease in the number of in meters. Distance traveled. And then at 5 seconds, you can see there's again a decrease from 28 to 31. That's a difference of what? 3 meters. Right? Now, graphical representation, very quickly. Distance in meters in the y-axis, and the other one in the x-axis. So you just plot it as it is, and then you're able to join the curve. Now, all these graphs, there's a way you can be able to look at them and know what is happening to the object that is in motion. We can be able to interpret. Now, number 5, how can we interpret now the slope? This one here, this slope, this is what you're calling the slope. What information can you gather from the slope? If you wanted to know what is happening in this graph, using this slope, what information can you get? So simply meaning, looking like this. The slope of a distance time graph is equals to what we call the speed. Now, the slope of a displacement time graph is equals to the velocity. Remember in the first slide that we discussed, we talked about velocity time graph, so distance time graph and displacement time graph. In this case, we have the following. The slope, remember this, that this point, from this point to this point, use the word run this distance here. From 2 to 4, run, and the next one we use the word rise. Run and rise. So the slope can be found by dividing the rise, which is the change in the distance. Change in the distance divided by the run, which is the change in the time taken. Change in the distance divided by the time taken. Now, the run describes the time, the rise describes the distance. How do you get these two values? As follows. One, you can look at that one. At 40, at this point, it is 40. And at this other point here, it is 20. You subtract those two, you get what? 40 minus 20. You'll be able to get a difference of 20 meters. That is the rise. What about the run? The time from 4 seconds, from 2 seconds to 4 seconds. 4 minus 2. If you describe that one, 4 minus 2, what do you get? You get 2 seconds. So when you divide that one, you get 20 meters divided by the 2 seconds. And then you get just as 10 meters per second. So this is the speed of this object. 10 meters per second. Now, one more time. If the slope of a distance time graph is similar to the slope of a displacement time graph, only that for displacement time graph, we will not be looking at the speed, we'll be calculating the velocity. We'll be calculating the velocity. Okay, now how can we summarize all this information? In brief, one slide. If you look at that graph number 1, a steep line, if you see a very steep line, this one actually indicates a very fast speed. An object that is moving very quickly, very fast speed. 2, but if you find another shallow line or a less steeper line, it actually indicates a slower speed. It's moving at a much lesser speed than the first one. Next one we have graph number 2. For graph number 2, you can see this curved line there. For a curved line upwards indicates what? The acceleration of the object. Acceleration of the object. And the last one here, we have a straight line means stationary. The object is not moving, 0 speed. Because at 0, it's at the same position. The distance moved is constant, is the same. There's no change. So a flat line indicates a stationary object with 0 speed. And the last summary here, we have this curved one here, which is opposite of this one. This is acceleration. This is retardation, or what we call deceleration. Looks something similar to that one. Indicates deceleration. Deceleration. Okay? Now, so far, so good. I want us to very quickly go to your time is almost up. I want to give you a short exercise to do. Slide number 16. I want you to scan this QR code. Scan this QR code, and then go straight to. Go straight to this this page. There's a worksheet there that I want you to do. You don't have to sign up. You don't have to sign up to be able to do the activity. You don't have to be a member of the website. You don't have to. Just the first few questions are matching, And the second few questions will be just drag and drop. Drag and drop. Okay, thank you. You can see the QR code there, and also you can see the link in the comment section. You can see the link in the comment section. You can click the link and go straight to that website, web page actually. When you click on it, you will be able to find a page that has all the questions that I want you to do. Now, you can submit or you can try to finish this in the next 48 hours. 48 hours, about 2 days. So now, all I want you to do is as follows. For those who are clicking in and highlighting it, make sure that now this is the worksheet. When you're done, click on finish. There's this button here, finish. Click on finish. When you click on finish, it will take you straight to another page where you enter your full name. Now, in your full name, I just make sure you write your name, your room, and your number. Your name, your room, and your number. You don't have to sign up to the website. You don't have to sign up. All you just need to do is just to click on the link. It will take you straight to that page. Do the exercise. When you finish, click on finish, then click on send. Don't forget the details of your name, your room, and your number. Okay? So I have about 5 minutes. I can wait for you if you have any question. How to enter your name? You can enter the name using, this is Piyasaran. Piyasaran. Type your name, either your nickname or your full name. It's up to you. But don't forget to write your room and number. Room and number. There's some example here on the screen. Name, room, and number. Because that is what I will use to identify who is who in the worksheets. Why does it say 119.995? Okay, it means you have like 119 days to do it. But the sooner you do it, the better. The sooner you do it, the better. How to enter your name? Again, the name is here. Another question, why does it say? Okay. Try and do it in the next 48 hours. 2 days, today and tomorrow. But if you can do today, fine, well and good. If you cannot do it, don't worry. If your internet is so slow, don't worry about that. The sun will still shine tomorrow, okay? Submit after 118 days. No. Submit after 48 days. That was a mistake. That was a mistake. Let me check. See, some of you have already logged in. Okay. And submit after 118 days. No, don't. Submit after 48 hours. That is after 2 days. After 2 days. That was a mistake. That was a mistake. Okay. 5 from 5, number 4, yeah? Okay. And then after that, click on send. Click on send. Okay. Any problem facing? How to enter your name? I've answered that one. Let me check. Okay. Two minutes remaining. 2 minutes. Okay. 5 from 8, number 12. Welcome. Okay. Novida says 180 days is better because it says that. Not at all. That was just a mistake. Okay, submit on start of the semester. No, click it when you finish. Just click when you finish, just click on send. You don't have to submit at the beginning of the semester, no. When you're done, just click on send. Okay. The graph can drag, but how to draw? Not the graph, but you just choose the answer and then drag to the correct graph. When is the deadline? After 48 hours, after 2 days. I believe the website more than any. That's funny, Novida. So no, don't submit after 118 days. Don't submit after 118 days. Okay, that's funny. Why I can't drop? Answering the last question. If you cannot drop, check again your internet connection. Check your net connection. Okay? So thank you very much. If you're having a problem, just take your time. You still have 2 days to try and do this one because we are running short of time. Is that okay? That is okay. Thank you for your time. Thank you for the activities that you're able to do. With this, I'll go through it again. You will see my work after. Novita, who are you? Make sure you write your name. That's a funny one, but that's okay. Take your time. Have a wonderful time, and hope again to see you next week. Thank you.